In this example, we're going to use synthetic division in order to divide this polynomial by the binomial x minus 3. So remember, when we're using synthetic division, we're dividing by a binomial in x minus k form, which means, since the x's and the minuses line up, that my k value is positive 3, which is really important because it's the positive 3 that's going to go out front here. So I'll put my bar. Okay, so once I have that first thing lined up here, so we have x minus 3, so my k is 3. Then for synthetic division, the only thing I'm concerned with are these coefficients. So I'm going to go ahead and write them all through. So 3, negative 9, positive 8, negative 24, negative 3, and positive 9. I'm going to go ahead and put a little box here because this represents my remainder. Okay? So the first thing for synthetic division is go ahead and bring down this leading coefficient, so 3, and then we're going to go through a process of multiplication and addition, multiplication and addition. So 3 times 3 is 9, and let's go ahead and add these up. So negative 9 plus 9 is 0. 3 times 0 is 0. Let's go ahead and add this column up. 8 plus 0 is 8. Multiplication, so 3 times 8 is 24. And then we'll add this column up. Negative 24 plus 24 is 0. And then multiplication again. 3 times 0 is 0. Add this column up for negative 3. And then my final multiplication will give me negative 9. So when I add this last column, I get 0 for my remainder. Well, having 0 for a remainder is pretty fantastic because that means this binomial evenly divides this polynomial. Okay, so let's go ahead and build up our polynomial here. We know that this is the remainder, which is 0, so this is the constant, this is the linear term, this is the quadratic term, the cubic term, and the quartic term, so x to the 4th. We also knew that we were dividing by a linear, so we could just take 1 from this leading degree here. So we had x to the 5th, so this becomes x to the 4th. Or you can count backwards. Either way, it works. So when I go ahead and finish building this up, this 0 indicates I have no cubic term, and this 0 indicates that I have no linear term. So my final quotient then will be 3x to the 4th plus 8x squared, and it's plus because this 8 is positive, and then minus 3 with no remainder. So when I divide the polynomial by this linear binomial x minus 3, I have 3x to the 4th plus 8x squared minus 3.